Okay, let's get started. Any questions about assignment 3? When's it due? Tonight, so any questions about it? Yeah.
So you leave an asked saying that the calculation is wrong, but for like the 4x course, is it outdated in the assignment?
It should be.
It's getting $11 instead of 10.
Yeah, that was my bad.
Okay.
Yeah. I can't, yeah, that should have been updated. I did upload it, but apparently it didn't upload. Yeah, it should be 1180, not 1080. And so this should be, I believe, 37.03. Somewhere around there. Any other questions? Should be pretty straightforward, yeah.
All right, I have a question for lab 4.
Lab 4.
All right, if we were to set an equation to find the median, do we have to declare a variable for the equation?
Not necessarily. So let's look at lab 4. So, median. So on the test, I asked you to print them in ascending order, right? So what things of these 4 numbers do you need to know? The middle 2, right?
Yeah.
So you don't need to know, therefore, the min and the maximum, right? Because you only didn't need the middle 2. So could I find what the minimum and maximum are? Yeah, so like on the test, you set it to be the first inputted variable, and then you just update the min and max accordingly for the other 3. Well, suppose I now know the min and max, what they are. How do I get the middle 2 numbers? Oh, sorry?
You can subtract maximum
From
the
the total, right. So I add up all 4 integers, and I take off the minimum, and I take off the maximum. What am I left with? I'm not left with the middle 2 numbers, I'm left with the sum of the middle 2 numbers. Does the sum of the middle 2 numbers help me find the median? Yes. Okay? So, but you don't necessarily have to use a variable for it, but it's a lot easier. Other questions? Yeah.
So, in that sense, do we, like, I'll talk about it.
Okay. Other questions? Okay, so let's get back into loops. So hopefully we'll finish loops today. So loops, as we have seen, are a way of repeating code over and over and over. And we stop according to when some condition eventually, hopefully, becomes false. So the one we saw first, way up here, was a while loop. So while some condition is true, exit the code in the between the curly brackets. Okay. Then we saw some other things that you could use to help manage your loops. For example, if you want a loop to run for a certain number of iterations, use a counter for it. Ways to control the loop via user input, and some other examples. And another one we saw was a sentinel, which means that if a user's inputting a lot of data, and then we don't know necessarily how much data is going to be inputted, we need a way for the user to say, yeah, I'm done inputting integers. So in this case, if they enter -1 at any point, then the loop will stop. And then we saw a variant on while called a do-while loop, which means the only difference here is that we are guaranteed to run the loop at least 1 time. Whereas with a while loop, it may possibly run 0 times. So can I convert any while loop into an equivalent do-while loop? Is that possible? Or are there some while loops I can't convert to a do-while loop that does the same thing? In fact, you can't, because if you take any while loop that runs 0 times, can I convert it to a do-while loop? Does that run 0 times? Or does a do-while loop always run at least once? Always runs at least once. So there are some problems that you can solve with a while loop that you cannot solve with a do-while loop. Although that's not strictly true, but it's mostly true for what we need to know. But do-while works exactly the same way as a while loop, except now we guarantee to run at least once, and we check the condition at the end versus at the top, although it's exactly the same thing because we'll go back to the top of the loop anyway. So yeah, so you can think of it as we're checking the condition on the bottom versus the top. And so why would you ever want a do-while loop? Well, if you want to ever present a menu to a user before they ever input anything, then you should show the menu at least one time. Because if you don't show that, then the user may not know what to do. So a do-while loop is great for a menu-driven application. Any questions on while or do-while loops? So there's actually a small error here. So these are directly from the publisher. What's the error in this loop? Can you see it? Do I ever update this choice variable? So what if it was? So what if choice was initially set to capital Y, for instance? What would happen in this loop? It'll run infinitely many times because I don't ever update the choice variable in here. I print another choice, but it's never updated. So what would I need to do to fix this? Put a C in after the C outline. But another one that I think is interesting that we didn't cover, but you should know, is this tuper or to-upper function. So what do you think this does? What do you think to-upper does? Right. So if we have a lowercase alphabetic character, it'll give us back the uppercase version. If we give it an uppercase letter, it'll give us back the same letter. Good, yeah. So why you would use this is, so instead of saying choice equals y or choice equals lowercase y, we can just say if the tupper of choice is equal to capital Y. Or another one is to lower. So there's a to upper and a to lower. Depends on what you want to do, but it makes the conditions for do-while loops, if you're using a menu, a lot easier. Yeah. It's only for chars. I think there's a function for strings. I can't remember it off the top of my head. So that would be something to know. Is there a function for strings that you can output the whole uppercase version of the string versus, or even just the lowercase version? Tuper and to lower work for characters only. But any questions on while and do-while loops? Yeah.
When would to upper and to lower be useful instead of just doing choice equal y and choice equal lowercase y? If they see it, to upper just seems like a lot of redundant wording.
What might be useful is in a switch case type thing. So if you have like case capital A, and then you also need a case lower a if you're going to handle that. So if you set the character to be to lower of the inputted character, then you only need to look at the lowercase ones. So to upper you can assign, of course, to a variable itself. Other questions? Okay, so let's look at the last type of loop. So while loops, although we have counters for them to count how many times we go through the loop, what is the primary use of a while loop? So why would we ever use a while loop? Yeah.
So that you can keep executing as long as the condition is true.
Right. We can keep executing as long as the condition is true, but do we know, unless we use a counter, how many times the loop will execute? Unless we use a counter? No, we don't actually know how many times the while loop is executing because that's something that we might want. the user may want to enter a whole lot of data or maybe not very much data. We don't know in advance how much the user will input. We can make a counter to say, yeah, you run this many times, but unless we do that, we don't know how many times we'll execute. A for loop, on the other hand, is equivalent to a while loop, so I can convert back and forth if necessary. But a for loop's main advantage is that it's set up to have a specified number of iterations of the loop. So, for example, if I want this loop to execute exactly 100 times, then a for loop is a good choice for this. For your assignment 4, which one do you think would be more appropriate? A while loop or a for loop? A for loop. Why? Yeah. Right. So we know the range of the A1, A2, A3, A4 variables, right? It's between 1 and 1,000. So I know as an upper bound how many times that loop will execute. So a for loop would be more appropriate. Could I use a while loop instead if I wanted to? Yeah. So it's equally valid to use for and while loops. It's just one is easier to work with in some situations versus another. It's all a matter of style. So how does a for loop work? So it's actually funky syntax, but let's try to understand what's going on. So you say for with parentheses, and then you have 3 parts of a for loop. So the first part is called the initialization step. So here what you can do is you can declare variables and other things if you want. So that initialization step will be run exactly 1 time. It'll never be run more than once. Then what will happen right after that is this test condition will be executed. So test here is like the while condition. So it's a condition we put here that evaluates to true or false. Ignore update for a second. So the test condition will be executed. Then the code within the for loop will be executed. So everything within the for loop executes. Then we go down to the bottom, come back up, and then now the update step executes. So update is then executed. And then after the update step, we check the test condition again. Okay? So let's just look at an example. So here, let's just say I declared an integer variable called count. It might be declared up here somewhere. And the initialization step says, I'm going to set it equal to 1. Here's a good exam question. Although, so now it probably won't be. But could I leave this initialization step completely blank and put nothing there? Do I have to declare something there? No, not necessarily. So it's just a matter of style again. Do you want to declare a variable there or not? Why would you want to declare a variable there? Maybe what you would want is if you declare a variable in here in the initialization step, then what is the scope of that variable if it's in the initialization step only? Could I access it outside of the for loop now? No. So that's something that you may want. You don't want to clutter your code before with additional variables that only are used for the for loop. So again, a matter of style. So the thing that we are checking against is this count variable less than or equal to 5? So which step is executed first overall? What thing is done first? The initialization step. So count is equal to 1. What happens right after that?
It runs through the statement and then it goes back up.
Right before that happens. The condition is checked now. Okay? So, although it kind of says right here, step 1, you do the initialization. And then now we operate kind of like a while loop. We then check the condition. So is 1 less than or equal to 5? I know it's early. Yeah, it is true. So then what happens? So the condition is true, what happens? We go into the loop. So here, since count is less than or equal to 5, we print hello and then a new line. And then, so now we're done executing the loop body. What happens next? We now go to the update step, which in this case, what does this thing do? Right, it adds 1 to the count. It does an increment on count. So after that one step right there, what is the value of count? 2. So now what do I do once I've done the update step? Do the test again, and then go through the loop. Update, test, loop, update, test, loop, and then keep going until when? Until the test is false. Okay? So it does operate like a while loop in some sense, because the checking of the conditions at the top, and then it has the loop body. So how can I convert a for loop into an equivalent while loop? Here's what you do. This initialization stuff, you put before the while loop occurs. The condition will be the condition of the while loop. The body of the loop is exactly the same, no difference. Where should the update expression go if I'm converting this to a while loop? Right at the very end, after all of these steps, right? Because we execute the stuff in the loop body, then we execute the update step. And then since that was at the bottom for a while loop, we go back and check the test again. But for the same reason, we can convert an equivalent while loop into an equivalent for loop. So that shows you that for loops and while a for loop into a do while loop always. No, what if a for loop executes exactly 0 times? Can I convert it to a do while loop? No. So, in fact, they are different beasts. Okay, so here's an example. So, I declare the variables before the for loop, but I could very well declare them inside the initialization part. So here, it sets num equal to 1, and then as long as num is less than or equal to 10, we add 1 to num. So how many times is this loop going to execute? How many times through? What do you think, just by looking at it? 10, right. Because if you think about it, 1 here, the num variable is telling you what iteration of the loop we're on. So the first time through, num is 1, so it's the first iteration of the loop. And then we keep adding 1 to num until the 10th iteration. We try to add 1 to num, but then the condition's false. So if, in fact, we're going to go through this loop exactly 10 times. And we can actually see this in action. So let's copy this over. Okay, so if we do this, it'll print 55. Yep, so, and yes, I did that in my head. But I could equally declare the variable, declare the variable there, remove it there. So I could equally do exactly that, but for this reason, I can't access the num variable outside the for loop now, for that reason. Okay, any questions on how a for loop works in general? What if I did plus equals 2 instead? What do you think this is going to try to do? So what things are we going to try to add? So 1 is the first iteration, but then what are we going to try to add the second iteration? 3, and then 5, 7, and 9. So how many iterations of the loop are going to happen this time? 5, but let's just check to be absolutely sure. The 5th iteration has num equal to what value? So first iteration is 1, then 3, then 5, then 7, then 9. So then we go to the update step and it says, yeah, add 2 to this number. So num is now 11. Okay? So is 11 less than or equal to 10? No. So therefore we exit the loop, so we do have 5 iterations. What if instead I said num equal to 0? How many iterations this time? I hear 5. Anyone have a different guess? It's actually 6. Why? First iteration is 0. Second iteration is 2. Third iteration is 4, 6, 8. Do the update step, which is now going to be equal to 10. Is 10 less than or equal to 10? Yes. So in fact, we'll have 6 iterations. Okay? So being able to understand how many times the for loop executes is actually kind of important. What if I instead said, I don't like that equal part, just make it strictly less than? How many times this time? 5, because then we'll skip that 10th, the num equal to 10 iteration. Good. Okay. So yeah, so if the condition is false the first time, then we immediately execute just like a while loop works. But as we just saw, the update doesn't have to be increment or decrement. It could be add 2. Could I leave the update step out? Like just remove it entirely? Well, let's see. Could I just leave this out? Yeah, what's going to happen now? It's going to run forever because we don't update the num variable anymore. Okay? What if, could I leave all 3 of the fields out? Well, let's check. Well, it's not really complaining. Well, I didn't declare the num variable anymore. So let's make the num variable say 1 to make that to make it okay. But what is this effectively doing now? Well, there's no initialization, that's fine. There's no update, again, that's fine. But what about the condition? There's no condition there. So what does it default to be if it's an empty condition? True. Yeah, so we've kind of seen this before, where we had an if statement that instead of double equals, we just put a single equals for assignment. So there's no condition there, so therefore the value is true. So exactly the same thing here. And in fact, if we hover over this, it says endless loop. Okay, so I can make an infinite loop equally well with for loops as well as while loops. Okay. Variables used in initialization should not be modified in the body of the loop. Yeah. So if you have like some counter variable that you initialize, you should really only update it in the update section and not in the main body of the loop. Sometimes you might, but it's not good practice because the update step is mainly there to update that variable or variables if you have more than one. Okay? Yeah, so the scope again, if you declare a variable here, it's only accessible within the for loop. Yeah, it could contain more than one statement. So here is something really interesting. So remember, what ends a statement in C++ normally? A semicolon. But here it doesn't. So here you separate things by commas now. If you have multiple things multiple statements in any of the initialization, or the update parts. So if you have multiple statements, put a comma there. I've never used more than one statement in my own code for this, but if you happen to, just put a comma there. Okay, yeah, you can omit so I guess I foreshadowed the slides by accident. You can omit initialization if you like, you can omit update if you like, you can omit the loop body, although this is kind of strange. You could omit anything in the loop body if you wanted to, and just make all the work inside the for loop. I think I've done this exactly one time, but it's very rare that you would ever have to do that. Because you kind of want to do some work in the for loop, or any loop for that matter, so leaving it empty is usually not a good thing. So which loop in general, as we kind of hinted at this. So a while loop is you check at the beginning, do while you check at the end, which means that the loop will execute at least once. And for is, again, you check at the beginning, but it's more used if you want to control how many iterations the loop occurs. Again, for and while loops are exactly equivalent. You can convert one and back to the other. So it's not like one does something and the another one does something else. It's just which one is more useful and easier to work with. Okay, but of course we can have nested loops. So I think this might be useful for your assignment 4. So nested loops are actually very useful. So you can have, so here it says update this, run this outer loop 3 times, and then run the inner loop 3 times for each of those. So overall, how many cout statements are we going to do? 9, because 3 for the outer loop and 3 for each of them in the inner loop. Okay? Well, for your assignment 4, suppose you're doing 1,000 iterations for the first variable, then 1,000 for the second one, 1,000, 1,000, and then finally one more 1,000 for the thing on the right-hand side. So that's 1,000 times 1,000 times 1,000 times 1,000 times 1,000. That's a colossal number. So if you just implemented this naively, then you have to think, well, how many iterations am I going to really do? Well, it turns out you're doing a lot. So can you cut those down by any amount? So that's what I'm asking you to do on your assignment 4. So none of these statements are actually true for one of the slides we're going to see in a second. But in general, the inner loop, unless there's something weird that's going to happen, the inner loop's going to execute all of its iterations before one of the outer one occurs. So like here, all 3 of these on the inside are going to execute before we update the one on the outside, as you might expect. So inner loop complete their iterations. These are copied from the slides. Inner loop complete their iterations faster than the outer loop. So total iterations is the product of the number of iterations of the 2 loops. This is not necessarily true. Anyone know why? We can have what is called a break statement. But if we had no break statements or any funky business that might happen, then it really is the product of the inner and the outer. Actually, that's not true either. But if you have 2 variables that have nothing to do with each other in terms of the initialization, update, and condition steps, if the row and the call variables have nothing to do with each other, then this is correct. It's the product of the number of times for each. But what if the call variable, hint, hint, has something to do with the row variable? Then it might change. So the number of iterations on the inside could change depending on what the number of row iterations has occurred so far. So determining the exact number is actually quite an interesting problem. But as I hinted, there's a little wrinkle in here in saying that if you want to exit out of a loop early, like with a while loop, you can do a break with a for loop as well. So it's mainly used if you know for sure you shouldn't do any more iterations of this loop. If you're for sure done with this loop, just break out of it and then you're all set. It makes code harder to understand. That is true, because now you have to think about, okay, when am I going to encounter that break statement? Because now it may depend on some conditions that might happen, and that may be hard to understand. So use it sparingly, but hint, hint, for assignment 4, it may be necessary. Hint, hint. Okay, but here's the interesting part. If you have a nested for loop, so an outer one and an inner one, and you put a break inside the inner one, it only goes out of the inner loop. It doesn't go out of the outer loop, which is kind of nice. So break only works with the current structure it's in, the current loop that it's in. Okay? So I would definitely think about using break for your assignment 4. But one more thing before we get into the next set of slides is something called continue. So this is actually kind of rare, and I've only used it several times, but it's actually really useful when it has a purpose. So here, a continue is kind of like the opposite of a break. So a break, remember, you exit the loop entirely. You're done with the loop. Continue says, if you encountered this continue statement, it skips the rest of the loop body and goes back to the top again. Okay? So, and this is used for all 3 types of loops. So it's not just for loops. But what happens here is you skip the rest of the loop body and then immediately go back to the top. Or I guess what do while you check the condition at the bottom. Was there a question? I think I saw a hand somewhere. Okay. So I don't think we'll ever use continue in this class, and I probably won't even ask about it on the test or anything. But sometimes it actually is useful. For example, if you want at least one thing to occur in some loop, then what would happen is if you have an if statement to check if this thing did not occur, then there's no need to check the rest of the loop body, and then you can just use continue. And then you have an else to detect when that thing occurs. And I've actually used that in my research for that exact purpose. So use continue sometimes, but break is far more common than continue is. Okay, any questions on loops in general? Okay, so let's get on to the next set of slides, which I posted 20 minutes ago, so hopefully you had enough time to prepare. All right, so you may have wondered, well, for the main function, why is it called main? Or why do we have to put an int there? Do we have to put an int there for int main? Well, what's a variant that I could do? Void. So some of you have seen somewhere else probably that the way that main works is that you don't have to return an int. You can have this thing called void. But you may think, well, we had this return 0 at the end of main. Well, why do we have to return an int? Well, could I return a double? Could I return a string? Could I return a character? What if I wanted to put some other function like this in my code instead of just main? Instead of putting all my code in main, I put some of the code in a different function. So that's what the motivation behind functions is. So why would you ever want to put all your code not in the main function? Well, so who thinks they have the largest number of lines for assignment 3? The largest number of lines. So how many you got?
230.
230. Anyone got higher? So would you want to manage 230 lines of code in one function, in the main function? So I know and have seen some functions that are several thousand lines of code, believe it or not. So, what's that? 402. So anyone want to manage his code and maintain it for the next 20 years? Yeah, so that's not an ideal situation. So what you would want is to have what is called modular programming, which is instead of having a giant chunk of code in one function, let's break it up into multiple functions that are easier to understand. So I kind of referred to this way back at the first lecture, I think, where I said you have to compartmentalize your thinking. So this is actually exactly what I was referring to. Trying to think, well, this block of code right here, does one thing, I'm going to put all of that and anything related to it in one function, and then just call the function. So I'm trying to separate all of the things I'm thinking about into multiple places. So if I need to maintain anything, then I can see, oh, okay, this function's okay, this one's okay, but this one has some of the problems. Now I can focus on that one function. It makes it a lot easier for us to work on. So what is a function? It's just a bunch of statements that does something, performs a task, simplifies the process, and improves maintainability. So we'll see examples of all of this, but a function call is a statement that causes a function to execute. So when the operating system calls main, that's a function call. Or when I call the POW function, that is a function call too. So we've seen several functions already where we have a name of a function and then anything we want to pass into it. Like for the POW function, we have to pass the base and the exponent. Okay? So some things we pass to the function, maybe nothing possibly, but then it'll give us a value at the end. Or it may modify the value, that sort of thing. The function definition is all of the statements inside of the function itself. So all of the code you've written inside the main function for all your assignments so far, that's the function definition of main that you've done. But of course, now we want to make other functions. Yeah.
Is something like getLine or toUpper, are those considered functions?
Those are all functions, yes. So anything, we'll see the definition of it, but anything that has some identifier with parentheses, other than if, else, while, all that. So like some identifier with parentheses and then some arguments. That is a function. Yep. So what are the things inside a function? So as I said, the name of the function. So like POW or getLine or toUpper, that sort of thing. Something called a parameter list. So if the function needs some values in order to calculate something, then we need to pass those in. So like for the POW function, what are the things that could be in the parameter list? Well, I need the base as well as the exponent. So I need two arguments, two parameters in this parameter list. The body of the function, that's the same thing as the definition of the function. But the return type is another something special. So, for example, the toUpper function, what is the thing that it needs in order to calculate the toUpper of it? It needs a what type? It needs a character. But what does it give me back so that I can use the result? It gives me back a character. Okay? So if I call toUpper on lowercase y, it's going to give me the character capital Y. Okay? So thinking about what return type you need for the function is actually pretty important. So I could, for example, make my own toUpper function that takes a string and returns a string. Okay? So I could make my own methods, my own functions like this. So here's like putting this in a concrete form. So the name of the function is the thing that occurs before the parentheses here. The return type, it goes before the name. So the name of this function happens to be main, and the return type happens to be int in this case. The parameter list is the thing that happens within the parentheses. And in this case, there happens to be no parameters whatsoever. And then the body is the thing that occurs between the curly brackets. Okay, so let's make our own function. So maybe we want to offload this, add all the numbers between 1 and some number, let's say 10. Let's offload that to a function. Okay, so maybe we need to think about those 4 parts. So what is the return type? What is the name of the function? Any parameters that we need, and what goes in the loop body, and as well as anything that we need to return. So what is a good name for sum all the integers from 1 to some number? So now we gotta think about, like, what is a good name for this? I could say sum all the numbers from 1 to some other number. And I could do that, but it's it's a little cumbersome. Yeah. What, sorry? People might not know sigma in this case, but I'll go with sum. But here, the issue here is that if we want to handle, say, 1 to 200, then I'm going to update the function instead of calling the function with a different value. So what could be the parameter that's passed in here? What should be a suitable parameter for this? Well, we all sum the numbers from 1 to some number. I think that some number should be the parameter that's passed in. So here we're going to say, we're going to make a variable here called int n. So, okay, so here the goal of this function is to sum all the numbers between 1 and n, and then return the result back to whoever called it. Okay, so if I call sum of 100, then I'm going to be returned 5040. Okay? Yeah.
Is there a way to return multiple values?
Not in C++. Although there's a structure, so if you look up pair, P-A-I-R, then you can tie two values together, but by default, there's no way to do that. Some languages, like anyone code in Swift for iOS or Mac? So Swift or Python, if anyone's done Python, those languages allow you to return multiple things at the same time. In C++, you can only return one entity, one thing. Okay, well, let's see. If I'm summing all the numbers between 1 and n, what thing should I return? What type should I return? Int seems suitable. Could I return a double if I wanted to? Yeah, I'm designing the function, right? So now I gotta communicate, okay, I'm expecting an integer and I'm giving you back an integer. Okay, well, if I had something like square root as the function, it's more suitable to give back a double instead of an int. So now I gotta think, what is an appropriate thing to return? So remember, the return type goes before the name of the function. So I'm gonna put int there. Okay? Well, let's see. So what should be the body of the function? So what are we trying to do? We're trying to sum from 1 to n in this case. So what should I do? Guide me along. Well, let's see. I gotta maintain this sum as I'm going through 1 to n, right? So let's see. What thing should I declare first? Well, I should declare an integer variable to hold this sum and then eventually give it back to whoever called it. So I'm going to make a integer result. I usually call these result, but you can, of course, call these whatever you like. Any variable name's okay here. So let's see. How many integers have I summed over so far? It's not a trick question. 0. So what should the sum be currently? 0. So I'm going to initialize it to 0. Well, let's see. So now I got a loop from 1 to n, and then add that number to result. So how do I do that? What loop is okay for this purpose? For loop. Right. So if I have a for loop here, and a great thing about CLine is that it figures out what you need to do. So if I push enter here, it'll actually fill out a lot of the loop body for me, which is kind of cool. So it made a loop control variable for me. It has an incomplete condition here. And then the update, well, is this the update I like? Well, do I want this one? Yeah. Could I put I++ there instead? Yeah, is that any different? No, not for this purpose. So, okay, so the only thing that we really need to change is this condition. So what thing am I going to keep looping over until I reach something? What am I summing over until I reach n? So it seems like this is fine. So then let's see. I want to add I to result. Okay? So how do I do that? Well, I can do this. So if I take the old result and add the current value of I and then store it back into result, then that's fine. What's a better way to do this? Plus equals. Yeah, so plus equals is better. Oh, I was about to ask that. Does this loop do what I want? Or am I missing one iteration? I'm summing from 1 to n inclusive. So what am I missing here? Less than or equal to. So I need a less than or equal to in this case. Okay, well, let's see. Now I got to give the result of this summation back to the user. So how do we do that? Return. So I actually haven't shown this in the slides yet, but like return 0, return some variable in here, as long as it's the right type, is what we want. Yeah. Well, if I put int result here, it won't work. Well, the I is going to have a problem, but here result is already declared.
Like, take out the int and just put result equals 0.
Yeah, I can do that too. Yeah, but the thing is now I need to declare this I variable. Yeah, so that's the usual convention is for loops to have I, j, k, that sort of thing. So that's why I put I here. Okay, so now how do I call this function? So let's see. So let's take this back. So instead of having sum here, it says sum of numbers from 1 to 10. How do I use the work that we just did to compute the result that I want? Sum parentheses 10. Okay, and if we run this, we should get exactly 55. Yeah. So now, instead of having all this computational work inside the main function, I have it hoisted out to some other function. So why is this better? Here, this function's only concerned about doing the actual computation. It's not focused on printing the result. It's not focused on any other work that's needed. Its only purpose is to compute the sum. So now I can be much more focused and say, well, maybe the user wants not inclusive, exclusive on the upper end. So instead of having to look through the main function and changing anything there, I can just change it in one place, and then I'm done. So that's why functions are so useful. You can compartmentalize your thinking and put one task associated with one function. Okay? And the great thing here is that we can have multiple functions. So I can have a function here and somewhere else, and then I can have them call each other. I can have functions call themselves if I want to, although we haven't covered that yet. I can do a whole lot with functions, yeah.
If you have two sub-functions, can you call them both in the same name?
What do you mean sub-functions?
If you have two different, sum, can you call it sum10? What if you have two different sum functions?
Great question. So if I had a different sum function down here, you notice right away, so let's just leave the implementation the same. What do you think this error is before I hover over it? It's already declared. What if I did this? Why did it go away now? It's now a different function, but it's named the same thing. That's pretty interesting. So that's something that we're going to see next time, which is called overloading. So I can have a name of a function be the same, but have two different functions, even though they're the same name. Any last questions? Yeah.
Can you initialize variables outside of the name?
Yes, and we'll cover those too, called global variables.
Maybe you can also put multiple
You could do that.